Hey guys, welcome back, and today we will be doing algebra. So algebra is a generalization and representation in symbolic form of meaningful results and patterns. So let's say you wanted to add two numbers, but you didn't know what those two numbers were. So the sum of two numbers. So we know that sum is adding or addition. So what that would represent is, let's say we call these unknowns x and y. So what that is saying is x plus y. So let's say x was 2 and y was, 3. Then that answer would give us 5. Let's say we want the difference of two numbers. We know that difference we're subtracting. So let's say we have x and y again. So it would be x minus y. Let's say x was 10 and y was 5. That means the answer would be 5. Let's say the product of two numbers. And product means multiply. So we're basically saying x times y, or we could simplify it as xy, which is the same as yx, because multiplication is commutative. So let's say, for example, x is 3 and y is 2. 3 times 2 would give you 6. Say we want to do the quotient. Of two numbers. And quotient means division. So that would be x divided by y, or we could simplify it as x over y. So let's say x was 10 and y was 5. That means 10 over 5. So 10 divided by 5 would give you 2. So let's say we had a number x and we multiplied x by 5. That means we would have 5x. So this number here is what we call the coefficient. And the x we would call the variable. So the coefficient is usually constant, meaning if you have a number, that number cannot change from itself. So if you have 5, 5 is 5. But if you have x, x is a variable, x can be any number, 1, 2, minus 1, 3, depending on what the question asks. So there are some rules for multiplication and division that we ought to know. The first one is, if you have a positive number, so let's say positive 1 times positive 1, so a positive times a positive gives you a positive. 2, let's say you have negative 1 times negative 1. A negative times a negative gives you a positive. So anytime you're multiplying and the signs are the same, you're going to get a positive. Number 3, let's say we have plus 1 times minus 1. A positive times a negative gives you a negative. 4, negative 1 times positive 1. This is basically the same thing, we just rearranged it. You're still going to get a negative 1. So once the signs are different and you're multiplying, you're going to get a negative. The same also applies for division. So 1, so a positive divided by another positive gives you positive. Number 2, negative divided by a negative gives you a positive. 3, positive divided by a negative gives you negative. 4, negative divided by a positive gives you negative. So once the signs are the same and you're multiplying or dividing, you're going to get a positive. Once the signs are different and you're multiplying or dividing, you're going to get negative. So another thing to ensure that you know, if you have a number 5 to the power 2, this is basically saying 5 squared. This is saying 5 times 5. And 5 times 5 is 25. Let's quickly do another one so that you get what I'm saying. Let's say you have 5a squared b. This is saying 5 times a times a times b. So the number in the power here tells you how many times something is being multiplied by itself. If you don't see a power, it means that there's a 1 there. So this would have a 1 here. That's why we only have it once. So let's say we have x is equal to 2, y is equal to minus 3, and z is equal to 4, and we are told to calculate 2x plus y. All we're going to do is we're going to substitute the value for x, which is 2. So it is 2 times 2 plus minus 3, because y is minus 3. So it is 2 2's, which is 4. Once you have this like this here, there's an imaginary 1 here at the front. And this is basically saying a positive 1 times a negative 3. Recall, when we multiply a negative and a positive, we're going to get a negative. So this becomes minus 3. And 4 minus 3 gives you 1. Let's try this other example. Let's say we have 5x minus 2y plus 3z. So it is 5 times x, which is 2, minus 2 times y, which is minus 3, plus 3 times z, which is 4. So 5 2's 10. So here, negative times a negative gives you a positive. So this becomes positive 6, and 3 4's 12. When you work all this out, you're going to get 28. So you have to pay attention to the signs. Let's say we're given x is equal to 2, y is equal to minus 3, and z is equal to 5. And we're told to find 5x squared z. So right at the 5, we know that x squared here is saying 2 squared times z, which is 5. So if you say 2 squared, you can put that in your calculator, or you can just say 5 times 2 times 2 times 5. So 5 times 2 is 10, 10 times 2 is 20, and 20 times 5 gives you 100. Let's try another example. Let's say we have 5xy squared over 9z squared. So it is 5 times x, which is 2, times minus 3 squared over 9 times 5 squared. So this is saying 5 times 2 times 9 over 9 times 5 times 5. And what you could do, because you're dividing and the signs here are multiplication, you could cancel the 9's here. You could cancel one of the 5's, and what you would have left is 2 over 5. Now let's try addition and subtraction of algebraic terms. So let's say we have 3x, x, half x, 0.5 x. If you pay attention to each of the x's, you would realize they're of the same power. Remember, if you don't see a power, that means the power here is 1. So each of these have the same power, so they are compatible to add or subtract together. Now pay attention to this. If we had 3x squared, x squared, half x squared, 0.5 x squared, these could not be added to these because the powers are different. So what I'm trying to get to you guys is once the powers are different, they're called unlike algebraic terms. So you could have x squared, x cubed, x to the fourth, continue. You can only add powers that are like powers. 7x plus x plus 12x. If we look closely, we realize that the powers are the same, so we know that we can add them together. Now, how do we add these? We look at the coefficients. So we're going to add the coefficients. So this is 7. Remember, if there's no number, it is a 1. So this is 7, this is 1, and this is 12. So you add those numbers together. So it's 7 plus 1 plus 12, which gives you 20. 20, and you just write back the x that was there. Let's try another one. Let's say we had 9x minus 5x. We look to see if the powers of the variables are the same. Yes, they are the same, so they are compatible to be added or subtracted. So what we do now, we look at the coefficients and we look at the sign. So it is 9 minus 5, which is 4, and we write back the x. Let's say we have 5x plus 15x squared plus 3x plus 2x squared. Now, I want you to realize that there are different powers here. So you look for the powers that are alike. This and this, this and this. Also pay close attention to the signs in front of each of these. So for the 5x, we have a positive 5x and we have a positive 3x. So we group those together. We have a positive 15x squared and a positive 2x squared. So what we do now, same thing. We look at the coefficients. 5 plus 3 gives you 8x. 15 plus 2 gives you 17x squared. However, when we're given questions like these, we usually write the numbers with the highest power at the front. So this is basically 17x squared plus 8x. Let's say we have another question. 10x squared minus 9y squared plus 5y squared minus 6x squared. Now you realize I dropped in a different variable, y. So now we're going to group like variables and ensure the variables that we group have the same powers. So the 10x squared and the minus 6x squared are compatible. This and this are compatible. So let's go. So we have 10x squared minus 6x squared. Then we have minus 9y squared plus 5y squared. Remember, the sign in front of the coefficient is very critical. So now we have 10x squared minus 6x squared. Remember, coefficient, coefficient. So we have 10 minus 6, which gives you 4x squared. And we have minus 9 plus 5. So if you owe 9 things and you pay 5, that means you still owe 4. So that means we have minus 4y squared. So now what we're going to try is multiplication and division of algebraic terms. So let's say we're given an example, 3x times 5y. First things first, what we do, we look at the coefficients and we multiply them. So it's 3 times 5, which gives you 15. We look to see if the variables are the same. If they're not the same, depending on what the power is, we write it back. So this, the power here is 1, so it is x. For the y, the power is also 1, so it is y. And that is all. Let's try when powers are different. Let's say we have 4x squared times 12xy. First things first, we multiply the coefficients. 4 times 12 gives you 48. Now, we look and realize that there's an x here and there's x here. Now, when you are multiplying, so it's x squared times x. This is called a law of indices. When you're multiplying the same bases, what you do is add the power. So remember that if there's no power, this is a 1. So because the bases are the same, we add the powers. So 2 plus 1 gives you 3. So this is 48x cubed. And realize that there's only one y there, so we just write back the y. Try some more. Let's say we have 5y squared times 3x squared y to the 4. So again, coefficients first. 5 times 3, that gives you 15. So realize that we have y squared and we have y to the 4. So again, y squared times y to the 4. The bases are the same, so all we do is add the powers. So 2 plus 4 gives you 6. Then pay attention to the x squared here. We have no x squared over this side, so it is just x squared y to the 6. Let's try another one with multiplication. Let's say we have 4p squared q3 times 3p cubed q. What we're going to get is 4 times 3, so coefficients first, 12. We have p squared and we have p cubed. So if we multiply those, we're going to add the powers, which is going to give us p to the 5. And we have q3 and q1. Add the powers, we're going to get 4. So now we can try some with division. Let's say we have 15x squared divided by 5x. Now, just like a while ago, if we are multiplying the same bases, we add the powers. When we are dividing the same bases, we subtract the powers. So let's go. So it's 5 into 5 goes 1, and 5 into 15 goes 3 times. So this is 3. So now we have x squared divided by x to the 1. So we subtract the powers. So that means we have 3x. So let's say we have this here. So again, pay attention to the division sign. So first it's coefficients. So 15 divided by 3 gives you 5. So you have an x squared here and you have an x here. So x squared divided by x, that means you're subtracting the powers. So it is 2 minus 1 leaves 1. You have y cubed and y squared. So it's 3 minus 2, which gives you 1 as well. Then you have z, and you have no z here, so the z remains. Let's try one last one. 20x y over 4x squared y cubed. So we say 4 into 4 goes 1, 4 into 20 goes 5. So now we have x divided by x squared. So we subtract the powers, we're going to realize that it is x to the minus 1. And we have y's, so it is y divided by y cubed. Subtract the powers, it will be y to the minus 2. We could have rewritten this in the same form that they gave us and say 5 over x y squared. So thank you guys for watching. I hope you guys learned a lot, and I'll see you guys next time.